In our day-to-day work, we make dozens of judgment calls about our workplace. We quickly pick up on obvious hazards, and we're trained to deal with most of these ourselves to make sure we have a safe work environment.
But a lot of the work in the mechanical trades gets buried. And when the job calls for us to work in an excavation, it can be a whole different ballgame. The hazards here aren't always as obvious, and it's harder to know how to correct them. Mechanical workers die all too often in excavation cave-ins, but excavation safety is still in your control. It may not be your job to fix the problem, but it's your life on the line, and you have to know when it's safe to enter an excavation and when it's wise to get out. We're going to give you the information you need to help you make those judgments. You'll never have to worry about working in an excavation as long as you take responsibility for your own safety. There's a common misconception that an excavation has to be deep to be dangerous. But even shallow trench collapses kill workers. The bottom line, soil is heavy. A cubic foot of soil weighs between 90 and 140 pounds. Whew. No matter how strong you are, it doesn't take very much of it to overpower you. A cubic yard of soil, and that's just 3 feet by 3 feet by 3 feet, weighs over 3,000 pounds.
That's about as much as a small pickup truck, way more than enough to crush a person. And you don't have to be completely buried. Even if your head and shoulders aren't covered by soil, when you can't move your chest and diaphragm, you simply can't breathe.
The point is, this should never happen. There are plenty of protective systems available that will prevent collapses, like shielding, shoring, sloping, and benching.
Shielding systems, or trench boxes, are frequently used in our industry because they can be portable. This allows us to move quickly along the length of a trench. But a trench box can't protect you unless you stay within its walls while working. It's also a good idea to get out of the trench box when it's being moved, even if it's just being dragged along the bottom of the trench. Shoring is usually built in place and consists of sturdy walls that are reinforced by wailers and held apart by spreaders. It's a system that's designed to withstand heavy pressure and keep you safe from cave-ins.
Now, don't be fooled by some rig thrown together with 2 pieces of plywood and a couple of 2x4s. If it doesn't look right, don't go down there. And meet with your supervisor immediately.
A simple but effective protective system is sloping back the sides of the excavation, or benching, cutting the sides back in ledges. These are both good ways of preventing the sides from caving in.
The angle required depends on the depth of the excavation and the type of soil. Soil that's dry and loose can flow, like sand or gravel.
The sides of these excavations require a more gradual angle to keep soil from sliding to the bottom. Dense, cohesive soil, like heavy clay, can hold its shape better and can support sides with steeper angles. There's a whole range of possible soil types. The cohesiveness of each type will determine the angle required for the sides of the excavation.
You're not expected to be an expert judge of soil conditions, unless you're the designated competent person on the site, with the training and experience to judge when an excavation is safe and the authority to stop the work if it isn't. What you are expected to know are the general principles that will affect your safety.
Never enter an excavation that's 5 feet or deeper unless one of the protective systems is in place and the competent person has inspected it and determined that it's safe to enter.
Any excavation that's more than 4 feet deep has to have some method of access and egress. The method used for egress has to be within 25 feet of where you're working.
This could be a gradually sloped ramp that allows you to walk in and out comfortably, or a ladder that extends 3 feet above the shoring or embankment.
Trying to climb on shoring or the sides of the excavation is inviting a fall or a cave-in. The idea is to get in and out safely. Even if a competent person has determined the excavation to be safe, you need to be alert for any changes in soil condition while you're working.
For example, water could start seeping into the bottom of a trench. This could indicate a problem with groundwater or the presence of a broken water main. Weather is a big factor that can change things quickly. In hot, dry weather, the soil can dry out rapidly. Soil in this condition could be less cohesive and more likely to slide. Too much rain could saturate the soil, turn it to mud, and cause it to become unstable. To make matters worse, if it were to collapse, the soil would be at its heaviest when wet.
Frozen soil that's hard and stable could be anything but that when it thaws out. If you see water in an excavation or cracks in the sides or top, get everyone out immediately and report it to the competent person.
Also, be aware of any surface encumbrances, like heavy machinery operating nearby or a spoil pile. Anything that could put a lot of weight near the edge of the embankment increases the risk of a cave-in. A rule of thumb is to keep everything back at least 2 feet from the edge. But severe loading, heavy traffic, or equipment that causes serious vibration could require more distance than that.
We've talked about protecting you from cave-ins, and while that's the biggest risk while working in an excavation, it's not the only one.
Dangerous gases leaching out of the soil or escaping from gas mains or sewers, or even carbon monoxide from nearby equipment can collect in low areas like the bottom of a trench. Some of these gases present flammability or explosion hazards, while others are extremely toxic. Before you enter an excavation, make sure the atmosphere inside has been tested by someone qualified to do so, and the competent person has determined that it's safe.
Finally, you have to expect the unexpected. In many cases, the excavation has already been dug before you get there. Hopefully, the utilities have already been located and marked. But if you're the one assigned to do the digging, make sure the underground utilities are clearly marked before you start. In either case, if your work uncovers a buried utility that you weren't anticipating, stop work and report it immediately.
It could be anything from a high-voltage electrical cable or an explosive gas line to a delicate telecommunications bundle. Wait for the competent person to make a positive identification and determine that it's safe for the work to continue. Our intent is to help you avoid hazards, but you also have to have a game plan in case something does go wrong. Knowing how to react quickly and correctly in an emergency can make a huge difference in the outcome of the incident.
The most important thing is, if you sense that something is not right, get out immediately. If you see a fellow worker in trouble due to a cave-in, your instinct will be to jump in and help. Don't do it. Too many workers are killed in excavation accidents while trying to rescue a coworker. The odds of you being able to resolve a serious incident by yourself are very slim. Besides putting yourself in grave danger, an accident victim could suffer more harm from a rescue attempt by an untrained person.
Call 911 and get a trained rescue unit on the site as quickly as you can.
Hopefully, that's something you'll never have to do. The safety systems that we've talked about make working in a trench or an excavation as safe as any other part of your job. But you have to participate to really make safety work. Learn to recognize the hazards and don't expose yourself to them. The things you're looking for are pretty straightforward.
A protective system like shielding, shoring, sloping, or benching should be in place. Surface encumbrances like heavy equipment or spoil piles are not increasing the risk of a cave-in. Adequate access and egress are provided. There are no harmful gases. All utilities have been located and clearly marked. And if conditions change, a competent person is on hand to reevaluate the situation.
As part of the mechanical trades, we're responsible for our work. We can't let quality slide because when we're done, it has to be right. And whether we're working in a high-rise or down in the trenches, we can't let safety slide either. It's our responsibility to make sure the site is safe before we start.